Picture this. You're standing on the coast of Scotland's Orkney Islands, watching waves crash against ancient cliffs. But floating in those rough waters is something extraordinary. A 680-ton yellow giant that's been quietly harvesting the ocean's endless rhythm since 2021. This is the story of the Orbital O2, the world's most powerful tidal turbine, and why it might just hold the key to our clean energy future. Welcome to Curiosity AI Podcast, Episode 16. I'm your host, and today we're diving deep into one of the most remarkable engineering achievements you've probably never heard of. While everyone debates wind versus solar energy, Scotland has been proving that the real renewable revolution might be happening beneath the waves. The Orbital O2 tidal turbine has been operating in some of the world's harshest marine conditions for 4 years now, and the results are nothing short of revolutionary. We're talking about a floating platform that generates 2 megawatts of completely predictable clean energy, enough to power 2,000 homes while saving 2,200 tons of CO2 every single year. But here's the kicker. Unlike wind and solar, tidal energy follows the moon's gravitational pull with clockwork precision. We can calculate its output centuries in advance. Today we'll explore how this yellow giant floating off Scotland's coast is transforming from experimental prototype to commercial reality. We'll uncover the ingenious engineering that makes it work, the economic impact that's revitalizing entire regions, and why countries around the world are now racing to deploy this technology. This isn't just about one turbine. This is about reimagining how coastal cities generate electricity. So let's dive in. Let me paint a picture of what makes the Orbital O2 so extraordinary. Imagine a floating platform 72 meters long. That's roughly the length of a football field. But instead of sitting on the ground, it's anchored in waters where currents regularly exceed 2.5 meters per second. At each end of this platform, massive rotors spin slowly through the water. Each rotor spans 20 meters in diameter. Together, they sweep over 600 square meters of area. That's the largest rotor coverage ever achieved on a single tidal energy platform. But here's where it gets really clever. Traditional turbines have to physically rotate to face changing currents as tides reverse direction twice daily. The O2 doesn't. Instead, its blades can pitch 360 degrees around their hubs. So as the tide changes from flood to ebb, the blades simply flip their angle to capture flow from the opposite direction. It's like having a wind turbine that never has to turn to face the wind. Genius, right? Now, you might be thinking, that sounds complicated. What happens when it breaks down? This is where Orbital Marine Power's engineers showed true brilliance. They designed what they call a gull wing system. Picture this. The entire nacelle and rotor assembly can be winched up to the water surface while the platform stays moored in place. Maintenance crews can access everything using small boats, not expensive heavy-lift vessels. We're talking about completing maintenance in under 40 minutes from dock to device. Compare that to fixed-bottom turbines, which often require complete removal to shore for major repairs. That process can cost hundreds of thousands of dollars and take weeks to complete. The O2 has been tested by some of the most extreme conditions on Earth. Hurricane-force winds in the North Atlantic, waves over 6 meters high, currents that would sweep away most structures. Yet it continues operating safely, automatically adjusting to extreme conditions like a maritime ballet dancer. The platform's survivability extends to every detail. Over 4,000 liters of specialized marine paint protect the steel structure from corrosion. Cathodic protection systems guard against electrochemical damage. The entire system is designed for a 15 to 20-year operational life in one of the world's harshest environments. So how has this engineering marvel performed in the real world? The numbers are impressive. Since connecting to the UK grid in July 2021, the O2 has consistently delivered 3 to 4 gigawatt hours of electricity annually. That translates to a capacity factor of approximately 20%. Now, if you're familiar with renewable energy, you know that strong performance for tidal energy and competitive with early offshore wind projects. But here's what makes it special. Unlike wind turbines that can sit idle during calm weather, or solar panels that produce nothing at night, the O2 generates power with remarkable consistency. Tidal currents naturally ebb to zero twice daily during slack tides. But between these predictable pauses, the turbine produces steady electricity following lunar cycles that can be calculated centuries in advance. There are no unexpected lulls, no surprise weather events, just reliable, predictable power generation. By 2023, European tidal stream generation reached 12.4 gigawatt-hours annually, with the O2 representing a significant portion of this output. More importantly, it has demonstrated that large-scale tidal energy devices can operate reliably year-round in commercial conditions. The maintenance record speaks for itself. Since 2021, the O2 has required 0 heavy-lift vessel interventions. All servicing has been conducted using small workboats and the innovative surface access design. Routine maintenance occurs during nap tide periods when currents are weaker, with technicians completing oil changes, bearing inspections, and blade cleaning in remarkably short time frames. But perhaps the most impressive aspect is grid integration. The O2 connects to Orkney's local network through the European Marine Energy Center. When grid demand is low, excess power feeds into a hydrogen electrolyzer, producing green hydrogen fuel. This represents one of the world's first demonstrations of tidal-to-hydrogen energy storage. The O2 isn't just an engineering success, it's an economic catalyst that's transforming entire regions. Let me share some remarkable numbers with you. Approximately 80% of the O2's construction spending flowed to UK suppliers. The Texo Group in Dundee built the main hull structure. Gray Fabrication in Fife contributed steelwork. Specialized components came from marine engineering companies across Scotland. This represented the first vessel launch from Dundee in 40 years, symbolically reviving the port city's maritime heritage for the renewable energy era. The construction phase alone supported around 60 full-time equivalent jobs, but that's just the beginning. Orbital's planned project pipeline promises substantial employment growth. The immediate array expansion, adding 3 upgraded turbines for a total 9.2 megawatt capacity, is projected to create approximately 150 jobs during manufacturing and installation. For perspective, this represents an exceptionally high jobs per megawatt ratio compared to mature renewable technologies. It reflects both the early-stage nature of tidal energy and its emphasis on local assembly and maintenance. The larger 30-megawatt Westray Firth project would multiply these benefits significantly. Orbital estimates over $120 million in domestic supply chain spending, hundreds of construction jobs, and approximately 12 permanent operations positions in Orkney. For remote island communities like Orkney, these represent transformational opportunities. We're talking about high-skilled marine engineering jobs in locations often limited to tourism and agriculture. The ripple effects extend far beyond direct employment. The O2's success has attracted additional marine energy companies, research institutions, and supporting services to Scotland's coastal regions. This clustering effect, similar to offshore wind's impact in coastal European areas, creates sustainable economic ecosystems around clean energy innovation. From a financing perspective, the story is equally compelling. Orbital's innovative funding approach combined $3.4 million from Scotland's Saltire Tidal Energy Challenge Fund, EU research funding through Horizon 2020 programs, and $7 million in crowdfunding through the Abundance Investment Platform. This blended financing model demonstrates how emerging clean technologies can access capital markets. The successful crowdfunding campaign particularly showed retail investor appetite for predictable renewable energy investments. The success of the Orbital O2 occurs within a broader context of evolving global energy security. As nations seek to reduce dependence on fossil fuel imports, tidal energy's unique characteristics offer compelling strategic advantages. Unlike wind and solar resources that vary across regions and seasons, tidal energy provides predictable output that can be calculated decades in advance. For island nations and coastal regions, this technology enables energy independence for communities traditionally dependent on expensive fuel imports. Scotland's investment in tidal leadership positions the UK to export this technology globally, similar to Denmark's dominance in wind energy manufacturing decades ago. International interest is already growing rapidly. Orbital has secured partnerships in the United States through Opalco for potential deployment in Washington state's tidal-rich waters. The U.S. Department of Energy has shortlisted this project for $6 million in development funding, potentially making the O2 design one of the first commercial tidal turbines in American waters. Similar opportunities exist in France, where Orbital participates in EU Horizon projects targeting Brittany deployments, and Canada, where Bay of Fundy's massive tides present compelling possibilities. The military and security implications deserve attention as well. Reliable, predictable power generation in coastal and island regions supports naval operations, coastal surveillance, and strategic communications infrastructure, while countries like China invest heavily in advanced nuclear reactors for maritime applications. Tidal energy offers a distributed, lower-profile alternative for maritime energy security. Smart grid integration represents another frontier where tidal energy's predictability provides unique value. Grid operators can plan dispatch with perfect accuracy, using tidal generation to provide stability services that command premium prices in electricity markets. The O2's demonstration of tidal to hydrogen conversion illustrates how marine energy integrates with emerging energy storage and distribution systems. Green hydrogen production using predictable tidal power could supply coastal industries, maritime transportation, and seasonal energy storage applications. Now, you might be wondering about environmental impact. After all, we're talking about massive rotating machinery in sensitive marine ecosystems. The results here are remarkable and reassuring. Over 10,000 hours of wildlife observations at tidal test sites have found no significant long-term changes in marine mammal or seabird distribution or behavior attributable to tidal turbine operations. That's an extraordinary validation of the technology's environmental compatibility. The monitoring covers all major concerns: collision risk assessment through tagged marine mammal studies, acoustic impact measurement using underwater microphones, electromagnetic field monitoring around export cables, long-term ecosystem health indicators. The results consistently show minimal environmental impact, with marine life effectively avoiding turbine rotors. The slow rotation speed of tidal turbines contributes significantly to their low environmental impact. At 10 to 15 RPM for the O2, these rotors move slowly enough for marine animals to detect and avoid them effectively. The blunt leading edges further reduce injury risk compared to sharp designs. From a carbon perspective, Orbital conducted a comprehensive life cycle assessment. Manufacturing and installation emissions are offset by clean energy generation in only 11 months of operation. For a device designed to operate 15 to 20 years, this rapid carbon payback demonstrates tidal energy's climate benefits extend far beyond simple renewable electricity generation. The O2's annual CO2 savings of 2,200 tons accumulate to tens of thousands of tons over its operational life. That's equivalent to removing over 1,000 cars from roads permanently. So what comes next? The transition from single turbines to commercial arrays represents tidal energy's next crucial phase. Orbital's immediate pipeline includes a 9.2 megawatt expansion scheduled for completion by 2026-2027, creating the world's largest floating tidal array. The larger 30-megawatt Westray Firth project, utilizing approximately 12 orbital turbines across a dedicated site, represents true commercial-scale deployment. With seabed rights secured and grid connections in place, this could become operational by the early 2030s, providing a template for larger tidal farms globally. Industry projections suggest tidal energy costs could fall below $90 per megawatt hour with around 100 megawatts deployed. That's a threshold Orbital's project pipeline is approaching. These cost reductions typically follow predictable learning curves, as technologies scale from demonstration to commercial deployment. The next generation O2X turbine, with its 2.4 megawatt upgrade and series production design, incorporates lessons from 4 years of operational experience. Lloyd's Register certification provides insurers and financiers with confidence essential for commercial deployment at scale. Looking globally, as countries seek to diversify renewable energy portfolios beyond wind and solar, tidal energy's unique characteristics create compelling value propositions. Predictability, minimal visual impact, and operation independent of weather conditions offer strategic advantages that extend far beyond simple electricity generation. The Orbital O2 tidal turbine represents far more than impressive engineering. Over 4 years floating in Scotland's harsh waters, it has systematically proven that humanity can harness natural forces for clean energy without harming the ecosystems we depend upon. From innovative maintenance systems to proven environmental compatibility, from economic revitalization to growing commercial pipelines, the O2 has addressed every challenge that once limited marine energy development. As coastal cities worldwide grapple with rising energy demands and climate commitments, the predictable power of the tides becomes increasingly attractive. The question is no longer whether tidal energy can work, but how quickly we can deploy it to help power our clean energy future. In the rough waters off Scotland, a yellow giant continues its steady work, proving that sometimes the most revolutionary changes come not from disrupting nature, but from learning to work in harmony with its eternal rhythms. Thanks for joining us today on Curiosity AI Podcast. If this deep dive into tidal energy fascinated you, make sure to subscribe for more breakthrough technology stories that are shaping our world. Until next time, stay curious.